We now go from one of the longest portions of the course, the ACL portion, to one of the shortest, route summarization. Don't let the length of this section fool you though. This is a vital real-world skill because no matter what routing protocol you end up working with out there, or all three of the big three, if you will, for our interior gateway protocols, RIP, EIGRP, and OSPF, they all have route summarization capabilities. Now the configurations are different, I'll certainly grant you that, but we know that between RIP, EIGRP, and OSPF at this point. I know that you haven't had EIGRP yet in your studies and you don't need it for this section, but you definitely need to understand route summarization for your CCENT exam. Also, this is a wonderful real-world technique and a great lab technique for keeping your routing tables, what I call, complete and concise. Because I want to remind you of this, because if you're watching the videos in order and maybe you're putting in a marathon study day, you just watched all those ACL videos, and we're always talking about, hey, it goes from top to bottom, and when there's a match, that's it. Well, that's ACL operation. In a routing table, we're going to look through the entire routing table for what we call the best match. And in that case, since we're looking through the entire routing table every time, it behooves us to keep that table complete and concise. And when we have a chance to summarize 4 routes with a single statement, or 8 routes with a single statement, or more, then we should take advantage of that opportunity. The route summarization we're talking about here is manual. There are some situations when route summarization is performed automatically. You are introduced to that in ICND 2, and right now we almost always turn that off anyway. I'm going to give you a preview of it. When you take your ICND 2 portion of the CCNA, I'm going to show you all about that, but we almost always turn it off. Because you and I as network admins, we want to be the ones to determine where route summarization happens. And we can do that with this skill and just a couple of quick commands. Here's how route summarization works overall. In this example, we have a routing update being sent from one router to another, 2 to 3 in this case, for the networks 104, 5, 6, and 7, all with a 16-bit mask. Now without route summarization, Route 2 will send an update containing the 4 individual routes. Doesn't look that bad, but if we can shorten that, that means that Router 2 will have a more concise routing table, but still be complete. When we summarize these, Router 3, as a result of getting a summarized update, will also have a more concise routing table, but still be able to reach everything that it needs to reach, because that's the key. When you're summarizing routes, it's not doing us any good to make the routing table more concise if we can't get to all the destinations we need to. So let's see exactly how we do that, because to configure a single route summary for these networks, or any networks you're ever given, write the network numbers out in binary. A skill that never leaves. And this is exactly how we do it right here. And of course, in the testing room or even on a piece of paper for your lab, you do not have to write out all these zeros, but I do show you that for completion's sake. And that's what we've got. Nothing tricky here. 100, 4, 5, 6, and 7, and you just write them out in binary. Now, do something tricky. There we go. Now here's how you get the route itself. Moving left to right, determine what bits each of the 4 network numbers have in common. Now I've bolded that for you here, but you want to be careful when you're going from left to right here. Not that you don't know how to go from left to right, but when you're going left to right, don't make the mistake of stopping at where the zeros are the bits in common. That's really the most common error when people get started with route summarization. You're going all the way left to right until they no longer have a bit in common. It doesn't matter if it's a 1 or a 0. So we can see that each one of these networks has the first 14 bits in common, because the 15th bit is 0 in these 2 networks and it's 1 in these 2 networks. So all you do is add up what you've got in bold. Basically, the resulting network number is the summary for the network. So if we use only the bolded numbers here, we're going to have 100 for the first octet, because that's what it is for each of the octets we're summarizing. And the network summary address will then be 4, because that's what is in common from left to right, and then when you add it up, we've got the 4 bits set to 1 right there. So that's 4, and that's it. That's all there is to it. We're not quite done though. Got to watch this on the exam. Now, if you try to just put the network summary into the router's not going to take it. But on the exam, of course, you could be given multiple choice, and they just show you different kinds of commands. And what you've also got to have to go with it is a mask. And most of that work is already done right here. We need a mask to go with that summary. The mask is determined by putting 1 in for each of the common bits of that summary network number and 0 for the I don't care bits. So it would be the first 14 bits, and so that's what we have in common. The first 14 bits are all set to 1, and everything else is set to a 0. And you know what that one is now, most likely just by looking at it. You know, you can do that one quickly. It's 255, 252, 00. Now the final summary address then is 100.4.0.0, 255, 252, 00, or using our prefix notation 100.4.0.0/14. You want to watch those on both your exam and in network documentation because they are the same. Because again, and this is a good practice exam question as well, and I've done this in a job interview quiz, what if you were asked what the summary was and you were shown 8 possibilities and it said, okay, select 2. And you'd be like, well, wait a minute, what do you mean select 2? There's only going to be one summary here I can use. Well, the thing is, one might be expressed with prefix notation, the other might be prefixed with a dotted decimal mask. So just remember that these are both the same. Now, the trick with route summarization is that it may include networks that don't yet exist. Now, the previous example is what I call a clean route summarization because it includes only the 4 specified networks and no others. But you and I know, especially in the real world, that's not usually going to happen. You're going to be having, 7 network routes, or 13. It's like, can we summarize these in a clean fashion? And what if the routes to be summarized then were 101, 2, 3, and 4 for the second octet? Well, if you go for the common bits from left to right, how many have we got there? We've got 13 because the 14th bit is 0 for the first 3 networks, but it's 1 for the 4th one. So we have 13 incoming bits. The resulting network number for that summary is 100,000. And then the network mask, the summary mask, I should say, is determined by putting 1 in for each common bit and 0 for the rest, resulting in a mask of 255, 248, 00. Nothing to it, right? First 13 bits. So the final summary address is 100,000, 255, 248, 00. Now, this address and mask are accurate for the 4 networks given. But what we have to be aware of is that this summary also includes 100.5, 100.6, and 100.7. Because if you added those to the list, they still all have the first 13 bits in common. So what you've done is not necessarily wrong. What you've done is created a summary that encompasses all the networks we were given. What we have to be aware of is that it also encompasses other networks that we weren't given. This doesn't make the summary address wrong, but it makes routing problems a possibility, not a certainty, but a possibility if those yet to be configured networks are placed elsewhere. Say in this scenario, because this could happen. I mean, this is real world. You've got router 2 and it's sending a summary of 100.1, 2, 3, and 4 to router 2. Excuse me, to router 3. So a year later, your network expands and you've got another router, and you put networks 100.5 and 100.6 in action on that router. So as a result then, router 2 is advertising a summary to router 3 that includes networks that are actually found on router 4. Now, I'm not guaranteeing you would have a problem here, but there is a possibility. So my strong advice to you, anytime you write out a table like that, that we saw with just dot 1, 2, 3, and 4. Keep going in that numeric pattern. Write out 100.5 real quick and say, okay, would this be included in the summary? And then just keep going. And again, not saying you shouldn't use that summary. I'm saying that you have to be aware of it if you have those routes in other parts of your network. You don't want to have a summary that's botching up your routing. That's not the point of what we're doing. Again, once you've got that summary address and mask determined, write out the next consecutive network number and see if the summary address would also represent that address. You'll save yourself a lot of headaches. Just check your connectivity afterwards. In that previous diagram, and let me go back to that, what you could do is when you set this up and say, okay, is this summary going to botch my routing up? Let me send some pings. Let me send some pings from router 3 to these two networks and see if they're all going down to 4 or if they're being load balanced between 2 and 4. There are all kinds of scenarios that could happen. But again, I know it's a dreaded buzzword, but being proactive there, taking the initiative and seeing if there's going to be a routing problem and then finding out about it then is a heck of a lot better than getting a phone call later saying, hey, something's really wrong with the network. Let's find out of a potential issue before it happens. Now, you know me, I hate to show you something and just the theory of it and then not actually do it. So I'm going to go ahead and fix up a lab for us here. Going to go a little above and beyond because I have to pick a routing protocol to do this with. And with RIP, we're just going to leave that alone because that's a thing of the past on the exams, except for a few mentions in the distance vector discussion. EIGRP, I know you haven't gotten to yet, and OSPF route summarization does bring in some more concepts you haven't seen yet. So what I'm going to do is set up EIGRP. You don't have to know anything about EIGRP. You don't even have to be able to spell it to understand the lab that I'm going to do. Obviously, I know you to spell it. But what I'll do is go ahead and stop the taping here, and on the next video, we'll have a simple EIGRP setup, just like the one you're seeing on the screen, where router 2 is advertising these routes to router 3. Before you go to the next video, especially if this is the first time you watch a series, go ahead and practice your summarization. Go ahead and see what summary and mask you would get for these 4 networks, and then we will put it into action and I'll show you the command and the result in EIGRP. So I'll see you on the next video. We'll do some lab work.